Start off, as we do with every substitution question, by differentiating my u term. 1 plus 2 tan x. Okay, so tan x from our formula book we know differentiates to sec squared. So du by dx, 1's going to disappear, so I'm ending up with 2 sec squared x. Rearrange this because remember the whole point is to remove all references to x from our integral and replace them with u's. So du equals 2 sec squared x dx, du over 2 sec squared x equals dx. Now, it's at this point that, and I mean, it's tricky to say that you always would do this because there's a previous question in this series where you wouldn't do this. But notice that this is over sec squared. Now, something over sec squared, that's the same as cos squared. So if we just go back to remembering our definition, 1 over cos, or 1 over cos squared, is sec x. Okay, so if we took the reciprocal of both of these, that would then lead us to thinking, or to knowing, that cos x is 1 over sec x. Okay, so for the purposes of this question, this is the same as writing cos squared x as part of my numerator all over the 2. Okay, so what I've done here is I've rewritten, and let's just use the highlighter, I've rewritten my sec squared, my division 1 over sec squared, as cos squared on the top. Okay, I'm just going to remove this little bit here, but we'll keep everything else for the remainder of this. So what we're trying to do, we're looking at this integral here, and we're trying to remove every single reference to x. So we'll start off by just sorting out the dx part. 1 plus 2, and then the sooner I can stop having to write that one out would be nice, over cos squared. And now dx is, and we're going to use this version, is cos squared x over 2 du. Okay, and this, once you've got here, you've got this question and it's nice and straightforward because the cos's cancel. If you haven't got to the point where the cos's cancel, then you're looking at this thinking this is a real tricky question. Okay, so I'm now integrating 1 over, now this fortunately is just u squared, save a bit of pen, and then I'm timesing that by du over 2. Now it depends on what you want to do, but for me I'm going to take this over 2, this half, out the front, and I'm going to rewrite that one to the minus 2. And now I've got the simplest integration that I could possibly want. Well, not quite possibly want, but anyway. Add 1 to the power and divide by the new power. So adding 1 to minus 2 gives me minus 1, dividing by the minus 1 there. And we are going to have plus c. We are looking indefinitely at integration here. We haven't got any limits. So what does this actually come out as? It's minus a half. And then look at it to be u to the minus 1. So we could put our u back in, which is 1 plus 2 tan x. So 1 plus 2 tan x to the minus 1 plus c. That's fine. Alternatively, and what the examiner might be expecting to see, what the first thing in the mark scheme is 2. And because, let's just use the highlighter again, because this is all to the power of minus 1, that is the same as having that as part of my denominator. So 2 lots of 1 plus 2 tan x there, plus the c. Okay, and that, either of those two are equally correct forms, worth 5 marks.